Good evening, everyone. Thanks a lot for staying with us today. I know that it is quite an evening already. I'll try to run through the slides as fast as I can. Exactpro is a software testing business. We started 10 years ago on 9th of September 2009. It is International Software Testing Day. And we are focused on mission-critical financial systems and infrastructures such as exchanges, clearinghouses, security depositories, and also technology vendors who provide software to them. We were part of London Stock Exchange Group for 2.5 years. Our management team bought back the company in January 2018. The company is headquartered in UK. We have offices in New York, London, Tbilisi, and in Russia. We started with 10 people on our team. Currently, we employ 590. Soon will be 600. 35 of them are working in our office in Tbilisi, Georgia. We work with exchange and clearinghouses and technology vendors in 20 countries on all 6 continents. This slide shows some of recent updates from our work. We helped a new regulated institutional grade infrastructure for digital assets to launch in Abu Dhabi. We helped Airbus Skytra to build their new derivatives platform. We work with Johannesburg Stock Exchange, etc. Exactpro works with a large set of clients and partners, especially relevant to today's presentation, today's webinar. We are platinum partner of Iosif. We also work with GasQ, and Exactpro also operates exam certification center in our office in Tbilisi. Today, I'll talk about resilience. Here's the definition. Resilience is the capacity to recover quickly from difficulties. It is used in psychology, in economy, etc. There are many good definitions of what it is and synonyms, and it is the opposite of fragility, vulnerability, weakness. So it's a good thing. It allows the systems to recover. And when we talk about mission critical systems, it is very important that they are able to recover quickly from difficulties. So when testing software for resilience, we need to do quite a lot of things. We need to subject large-scale systems to heavy load. We also need to simulate many different connections. We need to initiate component and hardware failover, switch off disks, network cards, power sources, etc., kill components, freeze components, etc. And we need to do it all in realistic manner under very heavy load. So this way we can try to establish whether our infrastructure like exchange or a clearinghouse that it doesn't have a single point of failure, or if there is an outage, it is able and has capacity to recover quickly. So based on the last 10 years of frequently painful experience working with software outages, working with large-scale systems, with as the 5 key features, key principles of the platforms that allows them to have capacity to be resilient. They are inevitability, observability, fidelity, substantiality, and agility. So what is inevitability? I'm very proud that Exactpro is a part of industry standard called Zero Outage Industry Standard. This organization joins effort from several leading technology companies working on define a standard based on the idea that we need to strive for zero business visible outages. So we need to do everything to make sure that there are no outages in the systems. And the standard works across 4 main work streams. They are platforms, people, processes, and security. So zero outage is a very good objective, and we need to do whatever it takes to achieve it. But one thing that is absolutely critical to keep in mind when you are building resilient platforms is inevitability. So inevitability means that no matter what you do, the outages will happen anyway. It is the main aspect of complex, large-scale technology, financial, societal systems, organic systems. So no matter how hard you try, there will come a day when the problem will happen. And if you think and if you work in assumption that something wrong will happen, you are ready. Oh, you are almost ready. If on the other hand, you assume that you can achieve the situation when the problem will not happen, then when it will actually happen, you are not ready because it comes to you as a complete surprise. Inevitability means that that outage is certain, it will happen anyway, and you need to figure out what to do. The question is not if, the question is when. Quite frequently, we are told that unrealistic test scenarios are the waste of time and nothing like this will happen. But once again, from our experience, we can see that unrealistic test scenario today is live service event tomorrow. Example, on one project, we were told to try to keep load level to double of historical maximum of the system. So over like 3 last years, we took the absolute maximum load that was absorbed by the system, and we were using it as the KPI for the platform. And then the day came when, due to recent COVID events, the load volume immediately jumped above this double. So never underestimate the probability of events with low probability. They are very likely to happen. And if you know that something will certainly go very wrong, it allows you to prepare. If you think that you can avoid problems, then you will not be ready. There is a nice symbol and a nice term called the black swan. It was popularized by a statistician, Nassim Nicholas Taleb, in his book called The Black Swan. And now during COVID-19 pandemic, some people say that COVID-19 is a black swan. So the black swan, up until some time in the past, people never observed any black swans. And that's why it was common knowledge that all swans are white. And black swan is an event that happens and we are not expecting it to happen. It is one thing. And the second aspect of black swan event is that it has a very dramatic impact, usually negative impact on everything we do. So it is something that we are not able to predict. But if we look at the Nicholas Taleb, Nassim Nicholas Taleb book, it was written in 2007. So it is more than 13 years ago. And in that book, he predicted that one of potential problems can be a global pandemic due to increased travel and due to the fact that we know that animal to human transmission is possible. So when somebody is thinking that current events like heavier load, problems with connectivity, etc., that we observed during COVID-19, that they are black swan, it is not correct. In reality, they represent a white swan. So we knew for many years that something like this will happen. But for some reason, we never took any actions. And the same happens very frequently when you do software testing for large-scale technology infrastructures. You expect that unrealistic scenarios will never happen and that they are black swans, but in reality, most of them are white swans. You know that they are possible, you know that they will happen, and only when they happen, you can say that, oh, what a surprise. The second feature is observability. There is something that happens most of the time when a major outage occurs. So outages happen in transportation, in finance, in every aspect of society. But when you investigate the large-scale disaster, there is one common element. And this common element is absence of adequate monitoring. So it can be absent, it can be inadequate, or it can be faulty. So monitoring is the difference between the problem and the disaster, between a problem and the disaster. When conditions head downhill and there is little time to understand what is happening, it is easy to respond with incorrect, reckless steps that will only make the situation worse. So for resilient platforms, one of the key components is monitoring. Monitoring should be thoroughly covered during non-functional test execution. Just an example of one of technology disasters in financial sector. It is well-known Knight Capital events when a rogue algo for 45 minutes was sending orders. Was sending orders into exchange. And as a result, the company lost $460 million US dollars within 45 minutes. It means that every second the trading algo was losing 170K US dollars. There are many aspects related to this particular disaster. Some of the people blame DevOps practices, not DevOps practices, but absence of correct deployment. Some blame insufficient test coverage. But one aspect that is present is that there were several monitoring and reconciliation utilities in the system. So there was orders reconciliation, trades reconciliation, balance monitoring, but none of them were given a clue of what is going wrong. So for 45 minutes, operators were looking at the system and they were not able to understand what's wrong. In fact, they made a wrong decision. So it appeared that the software was deployed on 7 servers and was not deployed on a single server, but configuration was deployed on all 8 servers. And it caused the problem on a single server. When operators incorrectly, due to faulty monitoring, they were not able to understand what goes wrong. So what they did is they rolled back the software from 7 servers. And instead of 1 faulty server, they had 8. So monitoring is one of the very, very key component of systems resilience. If you recall recent problems with airplanes like Boeing 737 MAX, the fatal disasters were related to monitoring when people misinterpret what the system tells them. So observability is extremely important. The next one is Fidelity. Software testing provides vital information about the quality of the platforms. And it must be truthful, because without access to objective data, we cannot learn from failures. Covering up the truth amplifies the negative impact of any problem or any human error. Frequently, it may be tempting to comfort stakeholders by reclassifying defects, decreasing their priority to paint a brighter picture of what's going on. But most of the time, it results in decrease in the platform's resilience. Even rejected defects are very useful because they provide substantial immunity against the real threats for the system under test. There is a great book called Black Box Thinking, and it explains how you can learn from failure, essentially. One of the takeaways is that aviation is safer comparing to medicine. It is very dangerous to get into hospital comparing to getting into a plane. Because when something goes wrong in aviation, there is always such a spectacular and such a tragic consequences that for every crash or even for near miss, there is always a proper investigation. And when it happens, people look into the black box trying to understand the root cause of the problem and to fix it going forward. In medicine, in healthcare, it's not always the case, because quite often people that go into the hospital, they are already ill, and frequently there is not really a cover-up, but there is not to the same degree desire to investigate a root cause of every death. And as a result, aviation at the moment is safer comparing to healthcare. So the truth may hurt, but lies kill, and it is very important for everyone who is working in software testing. If you want to have resilient platforms, objectivity, honesty is very important. Once again, if we'll get to COVID-19 events at the moment, so one of the major problems was initial cover-up of testing results, test data, etc., that eventually led to the global pandemic. So fidelity, honesty, truth is very important. We have a channel, Exactpro YouTube channel. One of them you might be looking at the moment, called Exactpro Vlog. And we also have the main Exactpro channel, and we put various interesting video about software testing there. This week, we will release the one related to a film called The Pentagon Wars about software testing and also testing various equipment. And it is a very good film about what is important in software testing. And the main thing that is important for resilient platform is truth and honesty. Software testing is relentless learning. So you always try to understand the system, understand the model behind the system. If instead you're trying to decrease number of defects to 0, you are not building a correct model of the system. The next one is substantiality. Substantiality is preferring essence over form. It is an accounting principle that says that essence is more important comparing to the form. So if you put something on paper and use it for tax evasion, it will not save you from the tax authorities because essence matter. The same is very relevant for reliable, resilient platforms and software testing. Essence is more important. So you should think about the real problems, not how they look on paper. Frequently, people trying to use various approaches to improve reports, to make the things less scary, or to concentrate on some things that are related to paperwork rather than assuring the real resilience and availability of the platforms. In many cases, people are following a cargo cult. Cargo cult is a thing that was observed on many Pacific islands after Second World War, where native population were building planes from trees and leaves in an attempt to replicate what they've observed on American air bases that were removed from the islands after the end of Second World War. So during the Second World War, there were many military bases, and they were bringing food, clothes, and other good things to these islands. And when the war stopped, the planes no longer arrived. So native population independently on many islands developed a cargo cult. They were trying to build a plane from wood or something like that, expecting that this will help them to bring food and clothes and other good things from the sky. Such things, so they were trying to replicate a form rather than essence of aviation. And such things happen frequently in software testing, where you're building a simplified model of the system. You can understand this simplified model. You can do test automation for a simplified model, but it represents a form of what you need, not its essence. So substantiality is extremely important. Once again, in the film Pentagon Wars, for one of the tests, it was necessary to check what will happen if there is a if there is a soldier in the tank. So what will happen when the tank hit? And the idea was to use a ship instead of a human. What happened is that people who were trying to delay testing, they insisted that it is very important to select particular ship that will be used during experiment and will be sitting in the tank. So it is important to keep the form instead of the essence. Frequently, you will encounter such things when you do various, when people try to look at the things, put checks into the boxes instead of trying to understand what's really going on and what can possibly go wrong, and use it to improve the system's resilience. Another thing why it happens frequently is that it is easier for people to concentrate on the things that are easier to understand. It is called bike shed effect. Of the following thought experiment. If you have a nuclear reactor and then a committee needs to approve plans for the nuclear reactor, then there is a very high degree of probability that they will spend quite a lot of time discussing bike shed for employees, because everyone understands how bicycles work, what is required from the bike shed. It is much easier to concentrate on the things that are easier instead of the things that are hard. So there's even a special name for that, bike shed effect. And the last one is agility. Agility is very important for resilient platforms, even though you can think that agile is not something compatible with mission critical environments. But agility is important because the only constant is change. And agility allows us to turn learning into action and action into change. And learning is the main thing that allows us to become stronger from failure. That is why if we want to have very resilient platform, organization and technology should have this feature, agility. Once again, resilience is the capacity to recover quickly from difficulties. It is not possible to recover quickly if you have no agility. To support software testing for mission critical large scale infrastructures, it is very important to build test harness capable of automated testing of such systems. So simulating all inbound, outbound connections, mimicking components, etc. Quite often, the complexity of such test harness rivals the complexity of the system under test. It means that if you would like to build such test harness, it is very important to have a separate stream that will be capable of building the test harness for the platform. And this work should start as early as possible, and it should go in parallel with the main software development process. The slide presents a picture of building a test harness that will go and be able to do deliberate software testing for the system in parallel with the main agile or waterfall development process. So agility is very important. We call the process build software to test software, where to build the test harness for the system, we need to develop software and use the software to test the system. What is presented on the slide is that to test, for example, market surveillance system, we need to build a simulation of exchange and algo trading participants. Or to test algo trading or exchange platform, we need to build market surveillance system. So in order to test something complex and something that needs to be resilient, we need to build a test harness. And the complexity of this test harness rivals the platform itself. That is why it is necessary to do it in parallel. True agility is achieved when you are doing it in parallel and when you allocate substantial and sufficient effort into maintaining the test harness. Thank you very much. You can find more information about us in our social networks. And thank you very much for spending the evening with us. That's all. Thank you.
Thank you, Iosif, very much for this nice and quite interesting presentation. I think even before and even after listening to this impressive presentation, the work the tester is doing, everyone will think that it's not simple. No, it's too complicated, and lots of things should be foreseen in advance and should be worked on different directions. And the truth, I really liked the part about the truth hurts but lies kills. It's one of the things that I think every tester should think. Before we will move to the next part of the webinar, there are several questions in our chat. I will go one by one. So first one is, how can we measure quality of our tests when performing resilience testing?
Yes, so the measure of any testing effort, once again, is essence over form. So what is essential for software testing? Essential for software testing is to tell the truth about the system. So if any of your tests are not capable of finding the truth, of finding defects, that they are of a low quality. Even if they are automated, even if they are well documented, but the main essence of software testing is to identify defects in the software and to provide correct information. So the best way to measure quality is whether they are able to identify these things. The second thing is you should never be afraid of the number of defects identified before they go live. So the more defects you find, the more information you have at hand. But the measure of good tests, the good testing is what happens after the system goes into production. So if you see that there are defects that were not picked by your resilience testing, then you have evidence that something is wrong. Another method commonly known as chaos engineering is to specifically introduce failure into the system. Some people introduce the failure into production system like Netflix. Some people do it in pre-production environments. Introduce a failure, like switch off particular component, and then see whether your resilient testing picked up it, whether it detected that something is wrong. Or you can introduce data corruption and then once again see if the testing was capable of picking up the problem or not.
Thank you. And there is a question about how can we measure quality of our tests when performing resilience testing?
Yes, it is the one that we just covered. Mm-hmm. So just
yes, sorry. The next one is what kind of skills are required for a tester to be able to perform resilience testing?
Well, so most of resilience testing in our company is delivered within non-functional testing department, and there it does require more technical background. So what will help if you know things like Linux or scripting languages like Python, Perl, or Bash command line, they will help to create scenarios capable of inducing failure into the system. Another thing, it is not enough to kill something and then check that the system had not collapsed. So it is necessary to check that the data is still consistent. And for data consistency checks, people frequently use SQL or, once again, writing scripting languages. So I would say that technical skills are important for performing resilience testing, and the rest are the same as for any other good software tester. You need to be able to identify problem. So you need to look into the system and try to find something that is wrong. So, but
okay, thank you so very much.